So we're going to continue this lesson. Now that we know how to simplify, we're going to look for patterns within simplifying. So the first thing I'm going to do is I'm going to look at these two factors. I have x plus 2 and x plus 2. And I'm going to see if I can find any patterns that I can see once I simplify those two factors. So I would be doing x times x, which is x squared. I'd be doing x times 2, which is 2x. And 2 times x, which is 2x, which gives me that 4x. And then 2 times 2, which gives me 4. Now, if you notice, within here, we have two different perfect squares. And if you remember, a perfect square is when we have something like 4 times 4, which would give me 16. Or 2 times 2, which would get me 4. Those are perfect squares. Or x times x, right? And within this equation, I have two perfect squares. I have x squared, which is a perfect square, and 4, which is a perfect square. Great. Let's see if I were to use that same pattern with x plus 3 and x plus 3, if I would also get two perfect squares. If you notice, I do. I would get x times x, which is x squared, and then I would add the two 3x's, which would give me 6x, and 3 times 3 is 9. I have two perfect squares in here again. I have x squared and 9. Okay? Same as in this pattern. I have x plus 4 and x plus 4. If I simplify all of those, I get x squared plus 8x plus 16. Two perfect squares here. I want you to take a look at this next one, x plus 5 and x plus 5. And just, if you need to, pause the video right now and see if you can find the pattern with that. Okay, and so once you have determined that, you'll notice that this is x squared plus 10x plus 25. Do I have two perfect squares? Yes, I have 25 and x squared. These terms, because you now know that these are called trinomials, all of these are called trinomial perfect square trinomials. Okay, these are examples of perfect square trinomials. Okay, let's look at some different patterns now. And all of these we did addition, and now we're going to look at different patterns in perfect square trinomials with negatives instead inside of our factors. And if you notice, we would do the same simplification process, and we would get x squared, we would get negative 4x, and we would get a positive 4. Do we have two perfect squares in there? Yes, we do. We have x squared and 4. Okay, I'm going to go through this a little bit quicker. And so if we looked at the next pattern with negative 3's, you would notice the same thing again. We have two perfect squares, x squared and 9. The middle terms in these are negatives, because if you did, let's look here, x times negative 3, you'd get negative 3x, and then a negative 3x times x would be another negative 3x, which would get me that negative 6x. I could find that same pattern if I had x minus 4 and x times x minus 4. That would get me this equation. I have two perfect squares. And so once again, go ahead and see if you could determine what the pattern of x minus 5 times x minus 5 would be, if you need to pause it. And you'll notice that that is x squared minus 10x plus 25, and you still have two perfect squares. So these would all still be perfect square trinomials. Okay? We're going to look at one more pattern. Okay, so in the previous two we did positive, positive, and then negative, negative. But what happens if we look at patterns that have positive and negative with the same two numbers within our factors? So let's walk through the process again of simplifying it. We have x times x, which is x squared. Then we have x times negative 2, which is a negative 2x. And then we have a 2 times x, which is a positive 2x. And 2 times negative 2 is negative 4. Well, if we're combining like terms, we're now left with 2x minus 2x, which is going to become 0. So now we're left with only x squared minus 4. You'll notice that we now only have a binomial left here because these two factors canceled each other out. This type of problem, because we have this negative sign here also, and we know that means the difference, this is called the difference between two squares. Okay, let's try it out with x plus 3 times x minus 3 and see what pattern we notice there. Well, I know x times x is x squared, and then I have x times negative 3, which is negative 3x, plus 3x, and 3 times negative 3 is negative 9. If I combine like terms again, this becomes 0. I'm left with x squared minus 9, which again gives me the difference between two squares. In both of these equations, you still have perfect squares.